Yeah, so if we don't know differential notation, number 29 and 18.2 is really hard.
Yeah.
If we do know differential notation, it's really easy.
Yeah.
Or at least it's hopefully easy. So what the heck would I mean by dx?
So we're just do negative sine t, right? Because it's doing t, yeah.
Oh, yeah. No, hang on, back. Just more in general, what would I mean by dx?
X prime.
Yeah, I mean dx dt times dt, right?
Yeah.
Really, I just multiply by 1. Or I think about the chain rule.
So we're going to extract our field from this.
Yeah, we could definitely extract our field from this. You guys see that? So what's the field I'm trying to integrate here? If I wanted to think about this in kind of a different way.
1 comma y.
This chunk is the integral over c of
dx.
1 comma y comma z, Mark says. You guys buy into that?
Yeah.
Dotted with d,
dr.
right? Because that's our field.
Yeah.
And then when we express it in differential notation, right? We just take the x component, we throw a dx on that. We take the y component, we throw a dy on that. Take the z component, throw a dz on that. Then we get this guy, which is really just the dot product boiled out. You guys all see that?
Mm-hmm.
There's not really anything else here. It's just the dot product once it's boiled out. So I've got dx, which is dx dt, and dy, which is dy dt, and dz, which is dz dt. So many dt's. Okay, so what do you do?
Plug in your values.
Just plug in values.
Yeah, plug stuff in. I recommend that you spend a second next to your term, right? So I've got my helix. It's x is cosine, y is sine, and z is 3t. Supposed to do from 0 to 2 pi, one term.
Yeah.
So what other information should I get from that before I start plugging all this jazz in?
We'll do derivatives, right?
Yeah, so I should find x prime of t, which is
Negative sine t.
negative sine t. I should get y prime,
Cosine t.
which is cosine t. And I should get z prime,
3.
which is 3.
And just plug those into the.
Yeah, everything goes in, and so my integral becomes the integral from
0 to 2 pi.
0 to 2 pi of what?
Negative sine t.
Negative sine t dt.
Oh, yeah.
You guys see that? I could add 1 dt here, or I could put 1 at the end.
With
Right.
all of them.
Yeah, I need a dt with either with each piece or way at the end. Your choice. I'm going to split this into 3 integrals, but do what you got to do.
Okay.
So then I'm going to do plus the integral from 0 to 2 pi.
Y cos t.
Y is,
Sine t cosine t.
yeah, so y is sine t, and then
Oh.
y prime is cosine t,
dt.
and then I got a dt. And then we're going to add the integral.
3t, or 9t actually.
Perfect. 3t times 3 dt.
0 to 2 pi as well.
And 0 to 2 pi as well. Perfect. Let's cool this?
Yeah.
Okay, so this one was, this jazz was the x. That guy's a y. The rest of this is a dy. This guy's a z. This stuff's a d. Cool. All right, then.
Anti-derivatives.
Yeah, go through and anti-differentiate each piece.
So negative cosine.
Okay, so I got negative cosine t evaluated from,
Negative, it's just cosine.
Yeah. No.
Yeah.
Sine to cosine. You got it.
I did that one already, right?
Yeah.
The other direction. Does it matter?
0 to 2 pi.
Yeah.
Oh, yeah. Sorry.
Yeah, what?
It kind of does.
Well, no, because it's going to cancel.
Oh yeah, because it's just gonna be zero.
It's the integral of a trig function over its whole period, right?
Yeah.
It's 0.
Yeah.
But it is positive cosine of t evaluated from 0 to 2 pi.
Okay.
And then what about this one? Plus,
Well,
I suppose I should zero that piece out.
yeah, we're going to do.
Okay, we're gonna have to do a u sub, right?
Yeah.
Okay, so we let u here be,
Sine
and then du is
cosine t dt.
cos t dt. Okay, so I get the integral of u du.
So one half cosine t.
What half sin t?
One half sine t. Sine squared t.
Hang on. What are your bounds?
Oh, 0 to 2 pi's. Oh,
Put them in
but
there.
just put them in
So
there.
they should-
Get the sign.
It'll be easier if I put them in here, I think.
Should be.
It'd just be
So
zero-
sine of 0's
0 to 0.
0. Sine of 2 pi's
0.
0.
So it doesn't matter.
Doesn't matter. Right, the area under a point is nothing. You guys see that interpretation? Okay. And then I've got plus, and this one's gonna matter, right?
Yeah.
This one's-
0 to 2. Integral 0 to 2 pi 9 t
Or
dt.
So it'd be 9
integrated
halves.
9 halves t squared
From 0 to 2 pi.
Okay, so I got 9 t squared over 2 from 0 to 2 pi.
Yeah, that's
So
gonna give you 18 pi squared.
So I'll get 9 2 pi squared over 2 minus 0.
Yeah.
Feels like 18 pi squared
Or number, yeah.
equals number. Good. Cool. What does this tell you?
You get some help.
Yeah. Right? If I start a little particle moving along this helix, right? It's getting some help from the vector field to get up there. Cool.
Perfectly fine.
Net help though, right?
Yeah.
You guys see that? It's net help. So if you just let it go, it might not make it there on its own. Does that kind of make sense?
Okay.
It doesn't necessarily
So you have to give
help
it-
all the way.
Yeah, it doesn't have help necessarily all the way. It just has help more often than it doesn't.
There's help in the z direction, but then the x
Yeah, and in
direction.
fact, here we could maybe, let's see.
The help along the circle alternates, but it's
Doesn't that be help
positive
against
along
it?
the z.
Yeah, so the x is always pushing kind of along x, right? The y component varies depending on where you are, and the z component is always up, right?
Yeah.
Because I'm always going up here. You guys see that? So it looks like x is always pushing off to the right.
Y is going back and forth.
Yeah, y is kind of going back and forth, but I'm definitely getting some help from the z. You guys see that?